Hello, and welcome to the Algorand Proof of Stake Show, a show by AlgoDevs for AlgoDevs. Here we explore the current state of the Algorand ecosystem by focusing in on interesting projects building out the decentralized future. I'm your host, Ryan Fox, developer advocate at Algorand. Today my guests are both colleagues of mine here at Algorand, and Kenyon, Senior Technical Product Manager, and Jason Paulos, Senior Software Engineer for Smart Contracts. Good morning to you both.
Hi, Ryan.
Good morning. It's great to be back.
Absolutely. Anne and Jason will be sharing updates included within the just released PyTeal version 0.14.0 and demonstrating for AlgoDevs how to author ARC4 compliant smart contracts. ARC4 is the specification for the Algorand Application Binary Interface. The Algorand ABI is both a machine and human readable JSON file describing the methods exposed by the installed smart contracts, and importantly, what is required as both input and the expected return types. There's a lot to unpack here today. Welcome, Anne and Jason, to the Algorand Proof of Stake Show.
Thanks for having us.
All right. Well, Anne, it's great to have you on the show. We recently heard from you at the AVM World Tour stop in Austin about the development roadmap and the upcoming releases. You've been with Algorand for quite some time in your role as Senior Technical Product Manager. Can you tell us what that entails and what brought you to Algorand?
Sure. Well, my job as a product manager is primarily to figure out what are the most valuable things that we can work on, that our engineering teams can work on. So I spend a lot of time interfacing with developers writing smart contracts on Algorand to understand what's easy, what's hard for them, what we need to improve, and then translating that into what we actually need to build or improve. I work on both, the AVM platform and PyTeal and related dev tools. And what brought me to Algorand? Chance brought me to Algorand, but I feel extremely lucky every day that it did.
Well, we're thrilled to have you here, and again, welcome to the show. Jason, to you, welcome back to the show. So the last time we had you on, you were showing the AlgoDevs the Wallet Connect protocol so they could easily connect their dApp to a mobile wallet. So how has your role changed since, and what are you working on now?
Sure. So I've had the pleasure of working on a wide range of things, all things Algorand pretty much, mostly focused on developers and end users. So as you mentioned, I was here about a year ago showing off some improvements to Wallet Connect and how that can work with the Algorand mobile wallet. But I've also worked on developer SDKs for Algorand, the AVM, and some opcodes there, and of course, PyTeal. That's been a thing that I'm happy to be involved with, and I've been working on that on and off for the past 2 years, really, since I've been at Algorand.
Outstanding. Well, we're excited to get into some PyTeal stuff here shortly. I wanted to ask you guys both one question, though. Can you explain for us just a little bit about the interactions between the product and the engineering teams, but then also with the AlgoFam community as well in regards to building and then refactoring software for the AlgoFam?
Yeah, sure. So it's a fun relationship, the engineering product relationship, fraught with lots of complexities. But our goals are aligned, right? At the end of the day, we want to build useful, impactful products. And I feel very, very lucky at the Algorand team, where we have a special product where our product is for engineers. So in this role, like the engineers are closer to the users than they usually might be. So our conversations are I'd say, very fruitful when I discuss with Jason what we should do in PyTeal on a very even footing. So it's a lot of fun.
Great. Yeah, I just add to that. It's definitely a team effort. We're tackling some pretty complex problems, so it's good to have input from developers, product managers, the community, everyone who is involved with Algorand. It's really good to know what they care about and what they want to see improved.
Outstanding. Yeah, really great insights into how this all happens. How do we get these releases out the door? And speaking of which, there was just yesterday, in fact, the release of PyTeal 0.14.0, which includes some great new features that I've been waiting for quite some time. So really looking forward. And AlgoDevs, if you are doing the play at home game today, you should just open up your terminal and do a pip install PyTeal -- upgrade, and you'll be able to play along with us today. So great. We're going to we're going to start with Anne. Let's go into take a look at those PyTeal updates, and we'll get an intro to what is the Algorand ABI, and then we're going to have Jason come back a little bit later and do some demos. So let's move to Anne. We've got your screen, so go right ahead.
All right. So for those of you, first of all, who might be brand new to the Algorand world, PyTeal is one of the two main languages for developing smart contracts on Algorand. And so we started this project of ABI support. I had never heard about an ABI before. People on the call, you may or may not have. So I had to have different people explain it to me, actually over and over, because it was a pretty confusing concept to me. But eventually it started to sink in. What is an ABI, this Application Binary Interface? At first I thought the A must stand for Algorand, but it does not. It is not an Algorand specific thing. So here's my favorite explanation that I found, my personal favorite. It might not even be the most correct one, but it clicked for me. So in general, an ABI is the interface between two program modules, one of which is often at the level of machine code. The interface is the de facto method for encoding, decoding data into out of the machine code. Random facts from Stack Exchange. So the Algorand ABI is the interface to call Algorand smart contracts and encode, decode any app call arguments and return values. So imagine the world without the ABI, right? I'm writing a smart contract. I have some method for my smart contract. It takes some arguments, and maybe it takes a string as an argument. Well, I have to encode that string somehow using Teal. And now, how is anybody else supposed to know how I encoded that string? Like, how are they supposed to call that method? Well, nobody else can, probably, unless I put a huge amount of effort into explaining it to everybody. And this works fine if I'm writing a smart contract and I'm writing the front end. I mean, it's more work for me. I have to figure out how I'm going to encode things in an efficient way. But then I call it from my front end and it works. But now the ABI presents a standard for encoding all kinds of types in these method calls so that everybody is on the same page. Everybody knows how you pass a string to a method in a smart contract on Algorand. These standards that have been implemented in the Algorand ABI were introduced in ARC4. If you're not familiar with ARC, the ARCs, it stands for Application Request for Comments, I think. And it's a set of standards and conventions for app development on Algorand. Things that the community discusses and agrees upon. The ARCs represent some kind of agreement from the community. You can check them out on the Foundation's GitHub. So ARC4 talks about how to make method calls, and the ABI implements all the standards from ARC4. So in practice, what does this look like? What does it mean to specify, the ABI for a method? Well, I have just a brief example here, which is the same example Jason will use in his demo. So here's the JSON description for the interface for this AlgoBank smart contract. And this is just the beginning of it. The first method. Here it's the deposit method. it takes two arguments, the payment and the sender, and you have the argument type here, and it doesn't return anything, and here's the description. Nice. Now you publish this JSON description, and now anybody knows how to call your smart contract. And before I hand it off to Jason, I wanted to just briefly look back at how we got here. So, we're always talking about roadmaps. What are we doing next? But it's nice to take a moment to reflect on how we got here as well. So the ARC4 was actually first created a year ago. And that's how long it took to get us to this point where we're releasing ABI support in PyTeal. We started with SDK support. So you can use the Atomic Transaction Composer, and it's ABI has ABI support. And even the ARC4 spec, right? It took a long time because you want to agree on the best standard that works for everybody. It's like a decentralized agreement mechanism, these ARCs. So it was eventually finalized, I'd say, in the spring. I mean, it might still get some wording tweaks, but the conventions are not going to change. And any expansions to the ABI will be in further ARCs at this point. And now here we are. In July, we're finally releasing this in PyTeal. I think when we started this journey, we probably underestimated the work involved here, but we're pretty proud of having arrived. And with that, I'll hand it off to Jason, who will show us some real demo.
All right, awesome. Thank you, Anne. I think you definitely get a better understanding of what an ABI is used for. So Jason, yeah, welcome back, and let's take us through some demos. How do we use this thing within PyTeal?
All right, sounds great. As Anne said, this demo has been essentially a year in the making, so I hope everyone enjoys the features that we're about to preview. Before we get into that, I wanted to just point out a few resources. This is the main PyTeal GitHub page. And as you can see, 23 hours ago, we did release this new version, 0.14. And among other things, some of the additions are ABI support. So we're going to dive into what that means for you specifically as a PyTeal developer, and we can show off all of the new features and behavior here. So I do want to also point out this is the actual specification for ARC4. You can find this on the Algorand Foundation's GitHub page. But this is the standard that the SDKs and now PyTeal are adhering to in terms of the ABI and smart contract interoperability. So if you're interested in developing with the ABI, I really recommend giving this a read, because this is going to have the source of truth for all the implementation details. And I think it's pretty interesting if you want to see what's possible. So other than that, we do have a new page in the PyTeal documentation. So down here, ABI support. This is a massive page that has all the details that you would ever want for writing an ABI compliant smart contract. And so I will just give a brief overview of the sections here, but I really encourage you to read through this if you're interested in using the ABI in a PyTeal application. So right off the bat, I'll just showcase there are a bunch of new ABI types that PyTeal is now supporting. And this is actually pretty complex thing to add to PyTeal. So there are a lot of details that you should be aware of. If you're using ABI types, this fundamental section covers everything you want to be aware of. So I definitely recommend checking that out. We also have 3 categories of types. And so I won't get into all of them here, but you can definitely visit this page, check out all of the new types that are now possible to use in the ABI with PyTeal. And there's some very exciting stuff here. Not only do we have kind of more basic types like integers and booleans, we also have compound types such as static arrays, dynamic arrays, tuples, and strings. So I definitely recommend checking out this page for more details there. Next up, you can now use ABI types in subroutines. So just a quick preview of that is you can annotate the type of your variable, of your input with an ABI type, and PyTeal will recognize that and actually package that type appropriately. So you can use these as subroutine arguments, and you can also, if you look at this section, use them as subroutine return values. And this is a kind of a unique thing with PyTeal. Instead of the return value being in the place you would typically expect in a Python program, all subroutines have to return an expression, a PyTeal expression, because that's just how the language works. So you will actually put your return value in this keyword argument called output. So it has to be named output, but you can change the type annotation to whatever value you want to return. And then in your subroutine, you can just modify this output variable however you see fit, and that will contain the return value that your subroutine has. So that's an important concept to be aware of, and we will definitely see that in the demo that I will show soon. Other than that, last two sections, we have creating an Arc4 program. And so there are two types of operations that Arc4 programs support. One of them is method calls, and these are kind of as you would expect. You name a specific method, you give it arguments, and it may have a return value that the caller should decode. And other than that, we have something called a bare app call. And these are application calls with no arguments and no return values. And they're typically used more for lifecycle events, such as opting into an application, updating or deleting an application, things of that nature. And so this last section we have here is all about, now that you have an Arc4 program, how do you actually call it? From two places, we have off-chain. So this would be either from an Algorand SDK, from the command line utility goal. So we have some pointers here for how to do that. And you can also now call an ABI method from another PyTeal contract. So we have this new function called innerTransactionBuilder.method call, and this will let you construct an inner transaction that invokes the method call on another ABI compliant application. So this is just a really huge feature, and you should definitely check this out if you're interested in doing contract-to-contract calls using the ABI. All right, so that is everything I wanted to show before the demo. I do have an instance of testnet running on my machine, and I just have the DAppFlow private blockchain explorer showing all the transactions here. And so this is going to be used for the demo. Before we start that, I want to show you the PyTeal source code that we're going to be looking at. And this example, it's called AlgoBank. It's basically a smart contract that acts as a bank for algos. So users can opt in, deposit algos, so they'll send it to the application. The application will hold those algos, remember who deposited them, and let you withdraw them at a later time. And so this is also available on this user guide page as well, as an example here. So you can definitely check this out on that page if you want to know more. Other than that, we can kind of dive into the code. I will start by looking at this router variable. And so an ABI router is what you use to create an Arc4 compatible contract. And so you would specify all of the bare app calls that you support right here when you create it. So I will quickly just give an overview of this section. We're basically saying we're going to support the no-op action during creation. So this is how you can create the contract. We will support opting in always by just having this approval here and call config.all. So users can opt in with the bare app call whatever they want. And then we have a special handler for closeout and clear state, transfer balance to lost. And what this does is it's an expression that reads the local state of someone who's opting out, and the algo balance will be held under this balance key. It will read that, and if they have a positive balance, it will send it to this lost global variable, because when you opt out of an application, your local state gets cleared, and so we're just counting any algos that have been lost by the users because they've opted out and they can no longer claim them. So moving on from that, the last two very sensitive operations, updating and deleting the application. We have another handler here, and this ensures that only the creator of the application, we're checking that the sender of the transaction is the creator, only the creator can perform these two actions. So this prevents any random person from updating your application or deleting it unintentionally, which is very important. So that is the beginning of the router. But what I think is the most interesting are the things that comes next. And so we have 3 ABI compatible methods that we are registering with this router. And the way that we do that, well, I guess the 3, first of all, we have deposit, get balance, and withdraw. And the way that we register these is we define the function that will implement the method. We register that function with this router.method decorator. And here, router is just the variable name that I called the router I created above. So we register the method with this. In this case, I'm saying you're allowed to call this method call with the no-op action and with the opt-in action. So you can opt in during deposit if that's something you want to do. And we can look at the arguments that we have here. So this method is going to take 2 arguments. The first argument is a payment transaction. So this is a pretty new concept to PyTeal, but you can have arguments not just be data types, they can also be other transactions that should be present in the same group. And so here for deposit, we need a payment from the user to the application account to actually transfer those algos. And that's what this is encoding here. And then we also have the sender as an argument so that we can ensure the sender of the payment transaction is available so we can modify their local state during this call. And so as you can see here, we can actually get to the implementation of this method. The first thing we're doing, we're just asserting that the sender that you sent us is actually the sender of the payment. And it's actually pretty straightforward to access the fields on this transaction argument. You just call the get method, and now you have access to a transaction object. And then you can access every single field that you would normally be able to access. So sender, receiver, or even getting the amount of the transaction down here as well. So we have some safety checks. We want to verify that the payment, the receiver of the payment is actually the application with the current application address right here, so that we are receiving the algos. And then we can modify local state to update that user's balance. So what's happening is we perform a local get to get that user's balance. And if they don't have a balance, it will return a default value of 0. We add the amount of their payment to that balance, and then we save it in their local state as well with a local put. So this is how the deposit operation works. And we can move on to the other 2. So the next one is pretty short. It's called get balance. And this just lets you ask what the balance of a user is, and it returns that value. So this takes 2 arguments. The user is an ABI account. This account is a special reference type, and it makes sure that the account that you're passing in as an argument is available for this transaction to read to and potentially write to as well, if they've opted to the application. And this is how you make sure that the appropriate foreign resources are accessible during the call. And this one has an output as well. It takes 1 argument and it has an output. And you know that this is an output because it follows the star, which is Python's keyword only operator. And so this is saying the return value will be a uint64. And we can see here we are setting the output variable. So we're setting what the return value is, and we're actually just performing a local get with the balance key to get that from the user's address. So in deposit, we modify the balance key, and here we're reading the balance key and returning it so you can access that. And the final method, withdraw, is how you get algos out of the application that you previously deposited. And this takes two arguments here. We have the actual amount that you want to withdraw and the recipient that should receive these algos. And this doesn't necessarily have to be the person who deposited them. I could withdraw the algos that I deposited to my friend's account, for instance. So we do have this as a second argument just to make that possible. And when we look at the implementation here, it's there's really two parts. The first is updating state so that we have decremented your account by that value. And the second is creating an inner transaction that sends you those algos. So they're actually moving from the application account to the recipient's account. And so this is kind of mirrors the deposit code, except we have a minus sign here instead of a plus sign. So we're taking away from the user's balance. And if this subtraction underflows, or it goes negative, there will be an error in the PyTeal runtime. So we don't have to worry about someone getting more algos out than they deposited, because that will fail this transaction. And then down here, we just create an inner transaction is a payment to the recipient. The amount is the amount that you've asked for, and we've already decremented your account balance. And then importantly here, we set the fee to 0. And normally transactions need a positive fee to be able to execute. So by setting it to 0, we're forcing the sender of this transaction to increase their fee so that on average, all of the transactions meet the minimum fee requirements. So this prevents this prevents the application from paying fees on withdrawal. You have to pay the fee if you're going to do that. Otherwise, we'll be taking algos from other users to pay this fee, and we don't want to do that. So those three methods, withdraw, get balance, deposit, those make up really the bulk of this application. And beyond that, we just have very few lines of code. We are calling the compile program method on this router. And this will basically create all of the expressions combine all these expressions into a single program. It will compile them to PyTeal source, and then we will get 3 outputs. So the first is the approval program for my contract, then the clear state program, and this is a completely new thing we haven't seen in PyTeal before. We'll get a contract object that describes the operations possible on that contract. And so here we're just writing these to files, and I will briefly show you what that contract looks like. The approval and clear state are nothing new. You've already been able to generate programs like this with PyTeal, but this contract JSON is new. So this is going to adhere to the Arc4 contract JSON spec that's defined in that document. And here we have the name of the contract and all of the methods that it supports. So we have deposit, get balance, and withdraw as well. And as you can see, all of the arguments are documented, both the type and the name of that argument. They're being extracted from the Python source that we just saw. And it also puts the return type as well as the description that was present in the doc string for this method. So everything you would need to know as a client is defined in this standard format right here. And this is going to be important because as a contract author, I will generate this to describe my contract, and then I can send it to whoever wants to call that contract. So this is a very important document. And we will now see, we're going to run a testnet demo that actually calls the program. Well, first it creates the program, and then it calls deposit and withdraw to actually see that work in real time. So I will show you. Let's see here. I have like I said before, I have a testnet node all set up. I've got 2 accounts. I'm just naming them account 1 and account 2. for convenience. And what I'm going to do first is create this app using goal. So this is nothing too special. It's just goal app create that you should have seen before if you are an Algorand developer. Right, so we're creating the app. It is pending. All right, and we have created this app. We have an app ID, so I'm just gonna create an environment variable with that. And I also want to figure out the app's address. So every app on Algorand has an address associated with it. It can hold algos, and we can see that that address here. Going to save that as well. So we have a new way to reference it. And then I'm going to fund that account because on Algorand, every account needs a minimum balance. So I'm just making sure that app account has that minimum balance and is ready to go to receive deposits. So we should be good right now. And we can actually check, let's see, this is our app address. I'm going to go back to my Explorer in here. And yes, we have 0.1 algos in here, and we are ready to go. So now I'm going to send a deposit from our second account to this application and execute that method. So this method, if you remember, is actually pretty special. It takes a payment as an argument. So there's going to be two transactions in this group, a payment and then the application call that invokes the AlgoBank app. So the first thing I'm going to do is create a payment transaction, but I'm not going to send it. I'm going to output it to this payment.txn file. And we've done that. And then the second thing I'm going to do is use this brand new goal app method command. And so what this is going to do is invoke the deposit method, and this is the method signature, and you can compute it from this document right here. The method signature, and then my two arguments. So the first is that payment transaction file, and the second is the account that is the sender of that payment transaction. And so when we execute this, what you'll see happen is it will create two transactions, an atomic group of two transactions. One is the payment to deposit those algos, and the second is the application call to actually call that. So let's see, it has completed. Just going to go back over to our Explorer, check out that transaction. So this is the application call. And as you can see in the local state delta, we set our balance to 1 million microalgos, or just one algo. And we can also look at the group, and you can see there's a payment transaction in here as well. So if we look at this, it will be from our second account to the application account with an amount of 1 algo. And yes, its balance has increased to 1.1 algos. So that's great. Why don't we try our get balance method to see if that works and returns 1 algo, since we just deposited 1. So to do that, I'm going to use goal app method again. And this one takes less arguments. So it only has 1 argument and it has a return value. So I just pass account 2 because I want to look up that account's balance using this method. So I'm going to send this now. And notice once this completes, we're actually doing something that's completely new. We are actually having goal decode and show us the return value from a method. And so this happens to be a uint64, but it could be a much more complicated compound type. It could be a tuple of multiple values with arrays and strings in there. And goal will parse those values for you and show it to you without you having to write any code. And that's really an advantage of having this standard mechanism for inputs and outputs to functions, sorry, to smart contract methods. And so we can see here our method succeeded with output 1 million, which matches the 1 million microalgos we sent earlier. So that is great. And lastly, I will just show you how withdrawal works. Another command here to withdraw an amount from that bank. And so I'm going to withdraw 250,000 microalgos or 0.25 algos back to my same account. And I'm doubling the default fee here so that we can cover the fee of that inner transaction. So this is now pending. All right, so let's look that up. So this is the application call transaction. As you can see, we've doubled the fee here. Our arguments are encoding the amount we want to withdraw. And local state delta, the balance key has changed to 0.75 algos, which is great. And you can also see in this Explorer the inner transactions that are part of this application call. So this is a payment from the application account to my account with a value of 0.25 algos. So exactly what we wanted to withdraw from this AlgoBank application. And lastly, I will just run that same get balance method again. We should see 0.75 algos as a result. So as soon as this finishes, we should get that result. And yep, succeeded with the output 750,000 or 0.75 microalgos. And I will just show you behind the scenes. If you look at this transaction, there is an application log. And this log is actually encoding that number 750,000 as a uint64. But we don't have to worry about the correct way to find this log, decode it, make sure we know that it's a uint64 and not, for instance, two uint32s, and display it. Because of the standardization with Arc4, Goal is able to know all of that and do all of those actions for us. So we don't have to write a single line of code. We can just use pre-built methods, pre-built commands and execute methods that other people have written. So this is in my opinion, a huge step forward for the decentralization of smart contracts, because no longer do you have to talk to the smart contract author to figure out the right way to call that method. It's all standardized in this JSON format that we have here today. So that concludes the demo that I have.
Great stuff, Jason. Just incredible to see how easy it is. And I know that you were showing us with Goal, but the other Algorand SDKs also have the availability for you to have those same encoding and decodings of the ABI as well?
Yes, that's correct. So every SDK we support, Java, JavaScript, Go, Python, they all have similar tooling to call ABI compliant methods as well. So it's really quite exciting.
Wonderful, wonderful. All right, well, we're gonna wrap this part up here. So I want to make sure that we know, how do we connect with each of you, and then most importantly, where can we find the PyTeal software?
Well, if you ever have any feedback on PyTeal or any Algorand products, connect to us on Discord is my favorite way. Obviously, you can submit GitHub issues as well, but on Discord, there's a product feedback channel actually that I and some other people monitor. So you're welcome to chat with us there.
Sounds very good. And Jason, to get the software, how easy is it?
It should be pretty easy. We've got the PyTeal GitHub repo, and we're on PyPy as well. So you can do a pip install PyTeal and have everything at your fingertips.
Wonderful. Well, Ann Kenyon and Jason Paulos, thank you so much for introducing the AlgoDevs to the latest updates in PyTeal 0.14.0 and to the Algorand ABI. It was a true pleasure having you both on the show with me today. Thanks so much.
Thank you, Ryan.
Thanks, Ryan.
All right, Algo fam. Well, until next time, until next week, have fun building on Algorand.